Okay, so we have an equation that we're ultimately going to solve by numerical approximation, which is a simple enough process, very similar to what we do for just ordinary differential equations instead of systems, because of course we have a formula for the rate at which the q vector changes. Okay? So knowing, once we get an equation for the rate at which the q vector, which consists, and I'm assuming we already understand the notation and everything, but the q vector, just to remind us, is the q1, q2 vector, where q1 is the amount of solute in tank 1, q2 the amount of solute in tank 2. So we're going to get a matrix that multiply by the q vector, okay, that represents the rate at which the amount of solute is changing, or at least the rate at which the amount of solute is changing due to the two concentrations. Okay? And we should be familiar with that. And then we have the rate at which the amount of solute in each tank is changing independent of the amount of solute in each, which is, of course, the inflow.
So if you wouldn't have any inflow, you would just have a homogeneous matrix?
If you didn't have any inflow or outflow, there's also an outflow. Well, actually, the outflow is going to depend on the two concentrations, so that wouldn't be over here. Okay? So this is going to be the inflow rate, which is independent of how much solute you've got in either container, right? Okay? In either tank. Okay, so what do you have for the inflow? Well,
Homogeneous or homogeneous?
as the vector is set up, the first component here relates to the first tank, the second component to the second tank, and there are more detailed ways you can understand that, but what's going into the first tank is 5 gallons of 0.1 concentration, which is 0.5 gallons per minute. Can't read that minute, I screwed it up. And over here, it's 0.6 gallons per minute. And this is the amount that goes into the first tank, the rate at which solute is pumped into the first tank, independent of the concentration, which of course is going to contribute to the rate at which the concentration in the first tank changes, and this similarly for the second tank. Okay? So that's easy to take care of because this doesn't depend on the concentrations. Okay, so what goes in the matrix?